Hello dear students, into this another video of the size reduction equipment. Today I am going to discuss about the colloid mill. As we are knowing that the particle size reduction in the colloid mill works on the principle of attrition, and basically as you are knowing that the colloid mill is suitable for the weight grinding. Basically the colloid mill consists of the rotating cone that is called rotor and the static cone which is known as the stator. Here this rotor and the stators are made up of the toughened steel or any of the metal. The gap which is present between this rotor and the stator, that will decide the particle size reduction which is obtained. Here, as the rotor is rotating, the attrition is going to be generated in the particles between the gap which is present between rotor and stator, and due to which the particle size reduction take place. The final size of the product that is obtained, that depends upon the homogeneous intensity, that is depending upon the speed of the rotor and the duration, the viscosity of the continuous space, and the clearance, that is the gap of the distance, and the shear force which is present between the rotor and the stator. Let's try to understand the working of this particular colloid mill by this particular demonstration. In the demonstration that is shown, that is one hopper is there into which the liquid is rotating, into which the solid particles are added. As the solid particles are added, the solid particles along with the liquid, because it's a weight grinding is taking place, so the solid particles along with the liquids are allowed to pass through the gap which is present between the rotor and the stator. And due to the attrition force which are generated, the particle size reduction of the solid particles will take place from this coarser to the very fine one, and these finer particles are going to be distributed throughout the liquids will be there. As here the particle size reduction of the solid will take place when they are in contact with the liquid or the slurry, so therefore it is suitable for the weight grinding. So it is suitable for the weight grinding. So here this is a motor which will try to control the speed of the rotor, and the gap we can control between the rotor and the stator. Now here again, look at this one. Now you are not finding any of the solid coarse particles, but it is going to convert to fine, and which are going to be distributed into this liquid very well. And furthermore, more solid particles are going to be added, and further this more solid coarse particle which are added, that are going to be converted into the coarse particle again. So now whatever the time or the duration we'll have to rotate this move this particular suspension, and then we decide what the final product we are getting. And the final product what we are getting after that, that is it's shown into this particular beaker will be there. Here you are finding this is the final product into which you find particles are going to be very well distributed throughout the liquid medium, and it is like a slurry, or what you can say like a semi-solid dosage form. The advantages of the colloid mill: it is simple in construction, easy to clean, suitable for the side direction of the wide range of material. Here the noise level is also low, and the wear and tear are also low because there's less rotating part. The disadvantage is sometimes the wear or the maintenance required for the rotor, that is the rotating part. Basically the colloid mill is having the wider application in the pharmaceutical field for the preparation of suspension. Basically suspension containing those solids which are not going to be easily weighted by the dispersive medium. It is also suitable for the preparation of some of the semi-solid dosage form for the grinding, dispersing, homogenizing of the semi-solid dosage form like ointment, creams, gels, and the highly viscous fluids.